So, Fun Sock Friday, the 4th of December. We're actually going to be looking at doing a couple sections today since they're both half sections, since we already did the first halves in Chapter 4a. So, today we're going to, write linear equations in standard form, okay? So, you guys are going to be able to write linear equations in standard form, okay? Yes, Jaden?
Every stapler.
Yes.
And staple.
Yes, hand sanitize, and then you can do that. Thanks for asking. Okay, so let's look at 4.7. So linear equations in point-slope form. Okay, linear equations in point-slope form, which we just did point-slope form, okay? We can also write them in this thing that we call standard form, okay? Standard is the word that goes in that blank there, okay? I'll write it in 1 second. So we can also write them in what we call standard form.
Yeah, standard.
Woo! Okay. Standard form is right here to the right. AX plus BY equals C. Now, to be perfectly honest, standard form is not like super useful to us right now. Okay? It becomes very useful later on in math. Okay? But right now for our stages, it's not incredibly useful, but we want to give you guys a good foundation of it now, so you've at least seen it before. When you get to later and you're like, oh, okay, yeah, I know this can be a thing. Okay? Does that make sense? Okay? So that's kind of the purpose of this. Is not because it's incredibly useful right now, but it's really setting you up for future success. Okay? So in standard form, all variables must be on the left. Okay? We want all the variables on the left side of the equation. You notice here, AX plus BY equals C, okay? A, B, and C, okay, are just numbers. Okay, those are integers, okay? So it's going to be like 5, 4, and 3, for example, okay? Those are just going to be numbers. X and Y, though, stay X and Y like they do in all of our other equations for lines. When we have like Y equals MX plus B, the M and the B change, but the Y and the X always stay the same. A must be a positive number, okay? A must be a positive number. So for it to truly be in standard form, we need A to be positive. Whatever's with the X to be positive, okay? A lot of times we'll call it our leading coefficient because it's the coefficient, the number with the variable, that leads the form. A, B, and C cannot be fractions or decimals. We don't want any fractions, nor do we want decimals. So what we're going to do is we're going to take these examples, okay, examples 1 and 2, and currently they're in point-slope form, okay? We can see the point is 3, 5, the slope is 1/3. And we're going to turn these into standard form, okay? You're right. So right now, this definitely isn't standard form because we can't have fractions, okay? But we're going to turn it into this AX plus BY equals C, okay? So we have a few different steps we're going to do here, okay? And this actually ends up being what we did yesterday, or we did last class, okay? With adding on a couple more steps, okay? So we're actually going to first get it into slope-intercept form and then change it from there. So we're going to distribute the slope again. Y minus 5 equals 1/3 x minus, what's 1/3 times negative 3? Negative 1. Very good, Isaac. Then we'll add 5. Y equals 1/3 x. Negative 1 plus 5 is? Positive 4. Positive 4. So we have y equals 1/3 x plus 4. Now this is slope-intercept form, right? So we started with point-slope form. This is slope-intercept form. Now we're going to take this and turn it into standard form. AX plus BY equals C, okay? So what we're going to do here is we said we want all the variables on the left. Well, the y is on the left, but is the x on the left yet? No, so we need to move this to the left. How would I move a 1/3 x to the left? Courtney?
You're going to subtract 1/3 x from 1/3 x, and then you're going to subtract it from the other side too.
Very good. We're going to subtract the 1/3 x on both sides. Now, do we know what... Can we actually do like a y minus a 1/3 x?
No, but you can write it.
No, but we can write it. And we're going to actually write the x first. Okay? And the reason why is because if we look at standard form, which one comes first, x or y? Which one comes first in standard form? X or Y? X comes first. We're putting them alphabetically. So we have negative 1/3 x plus y equals 4. So now we have all the variables on the left, like it says we want them. But is A positive? Is the one with the x, A is with the x, is A positive right now? No. And do we have fractions? Yeah, we don't want either of those things. So we have to think, okay, well, what can we do to this equation to make A positive and not a fraction? It's currently negative 1/3. Well, we can multiply everything on both sides of the equation by a number. What would we have to multiply by to get it to be a positive number? A negative number. And we can multiply it by 3. That's going to get rid of that fraction, won't it? So we're going to multiply the left side by a negative 3. And so that means we have to multiply the right side by the exact same thing, a negative 3. Once again, we chose negative 3 because we know a negative times a negative will make it a positive like we want. And a 3 will get rid of this fraction since the denominator is 3. So if we distribute here, negative 3 times negative 1/3 x, that's positive 1x, or just x, if you will. Negative 3 times y, negative 3y. 4 times negative 3, negative 12. Now that we have it here, does this look decently similar to the ax plus by equals c? I think so, okay. Well, are all variables on the left-hand side of the equation? Yeah. Is a positive? Yeah. It's positive 1. And are there any fractions or decimals? No. So we hit our checklist. We hit our 3 requirements to get this into standard form. And I'd be like, Mr. Costa, that was weird, okay? That was weird. Why did we do all this, okay, that kind of stuff, okay? Once again, this isn't incredibly helpful to us right now. We're just setting up for future success, okay? Learning how to do standard form because it is helpful later. Sarah? Are you saying like try and like not have a 3 there either? Like try to have that be a 1? Yeah. You actually can't manage to both have the x and the y's both be 1s and then still be on the left-hand side. So yeah, great question though, okay? So our main concern here, okay, Haven. Our main concern here is really that this in front of the x is positive and no fraction. As long as we meet those two, then we're okay with what the numbers are. Let's look at number 2 so we see another example, okay? We're going to follow the same steps. And I'm actually going to make them in the same colors, so maybe we'll kind of associate that. That might help us, okay? So we're first going to get this into slope-intercept form, and then from there we'll convert it into standard form. So our first step is going to be to distribute that slope again. Y minus 1 equals 7x plus 35. This is the same kind of thing we did for the homework today. Then we'll add the 1. Y equals 7x plus 36. So now we have our slope-intercept form, and now we want to turn it into standard form. So once again, for standard form, we have this checklist. All variables on the left, A must be positive, A, B, and C can't be fractions. None of the numbers can be fractions or decimals. Okay, well, are all variables on the left right now? No. Okay, Jocelyn, what variable do I need to move to the left? The 7x, okay, how do I move that? Subtract it, very good. It's positive, I'm going to subtract it. 7x minus itself is 0. Which one do I want first, the negative 7x or the positive y? Negative 7x. Hey, Alice, would it be better for you to move up to this empty desk today?
Wait, so
Okay.
We subtract the negative 7, the 7?
Yeah, we subtract 7x.
We don't divide it?
No, so we're trying to move it to the left-hand side. So whenever you're trying to move the entire thing, we'd have to do the opposite of what's there. So 7x is adding with 36. The opposite of that is subtracting the 7x. So we have negative 7x plus y is equal to 36. So now, all variables are on the left. Is A positive? Is the number with the x positive? No, it's a negative 7, okay? Well, are there any fractions or decimals? No, okay, so we don't have to change. We don't have to worry about that last part, okay? So we have variables on the left. We have no fractions or decimals, but we need A to be positive. What can I multiply a negative 7 by to make it positive? Courtney? Negative 1. Any negative number. And I would suggest, why not pick the smallest negative number possible? Negative 1 is easier to multiply by than like negative 2 or negative 3, for example. So let's multiply both sides of the equation, because we have to do it to everything to make sure it's fair and equal, okay? is multiply everything by that number. So negative 1 times negative 7x, positive 7x. Negative 1 times y, negative y. Negative 1 times 36, negative 36. So then we can ask ourselves a question, okay, variables are on the left, a is positive, a, b, and c are not fractions or decimals. No fractions or decimals. Okay, we are good. This is standard form.
Would you be dividing? Because you're multiplying there, so.
Say that one more time.
So wouldn't you be dividing by negative 1? Because negative 7x are multiplying. So.
Okay, great question. So wouldn't we divide to undo the negative, okay? So you actually could think of it either way. Because whether you multiply or divide by negative 1, the result's actually the same. Because if I take, let's just say for example off to the side, okay? If I take 5 divided by negative 1, what do I get?
Negative 5.
Okay, and if I take 5 times negative 1, what do I get?
Negative 5.
Negative 5. So either way you think about it, it actually is the same. So if you want to divide every single thing by negative 1, because that makes way more sense to you, go ahead and do that.
Right.
And if it makes more sense to you to multiply by negative 1, go ahead and do that. Okay? That make more sense?
Yeah.
Awesome. Great question, okay? Any other questions that we have on this? All right, let's continue on. We just have a couple more examples for this section. So y equals 3x plus 5. This is nice because this is already in slope-intercept. So the first part of the problem, which we did here in the purple on the previous examples, we don't have to do because we're already at the end of the purple. So we want this into standard form, which just as a reminder, standard form is ax plus by equals c. So I want all my variables where? This is kind of mental checklist we want to think through. Variables on the left. So what variable do I need to move, if any? Hey, Brady.
3x.
3x. How do I move the 3x, Brady?
Minus 3.
Very,
Do the same to the...
very good. We'll subtract 3x on both sides, okay? Which one do I want written first? The negative 3x or the y? Negative 3x. We have to make sure we take the negative with the 3x, right? Negative 3x plus y equals 5. Okay, go through my mental checklist. All the variables on the left. Okay, good. What else do I need to make sure of? Jaden?
The x is not negative.
Okay, the number with the x is not negative, okay? It is negative right now. We need to change that. What else do we need to make sure of? No fractions or decimals. Do we have fractions or decimals? No, okay, so the only thing we have to worry about is the negative. Well, how do I take care of that negative?
Divide by negative 1.
Divide or multiply by negative 1. It really doesn't matter which. We've been multiplying, okay? I can show you that we can divide it as well. Let's say I divide every single thing by negative 1. Once again, we have to do it to everything. Negative 3x divided by negative 1, positive 3x. Y divided by negative 1, negative y. 5 divided by negative 1, negative 5. Either way, whether you multiply or divide everything by negative 1, you get the same answer. Now, mental checklist. All the variables are on the
Left side.
left side. Okay, good. Do we have any fraction or decimals?
No.
No, okay. Is a negative? Is a leading number negative? No, okay. We are good. Questions on that? Okay, let's look at this number 4 here, okay? Mental checklist. Okay? Are the variables where they're supposed to be? Okay? Raquel, what do we need to do to get the variables where they're supposed to be? Subtract 1 half x. Negative 1 half x plus y equals 1. Okay, mental checklist. Are all the variables where they're supposed to be? Okay, good. Okay. Do we have negative? Do we have a negative leading coefficient? Is a negative? Is the number with the x negative? Yes. Okay. Darn it. We want to change that. Okay. Okay. Do we have fraction decimals? Yeah, we want to change that. Okay. So how am I going to get rid of this negative 1 half with the x? Okay, Courtney.
You can multiply by negative 2.
I love that. Multiply by negative 2, or if you'd rather think of it as a negative 2 over 1, that's definitely great as well. Multiply both sides, every single thing, by negative 2. Now, Courtney, why did you choose 2? Why not like 3 or 4? We chose 3 last time. Why 2 this time?
I chose the negative because these go to the same sign to make it positive.
Okay, love that.
And then the 2 because the half plus another half equals a whole.
Okay.
It's a whole number instead of a fraction.
Okay, So that 2 times a half will equal a whole. Those 2's will reduce, won't they?
Yes.
Yeah, those 2's are going to reduce. So we actually, Courtney just chose the same number as what was there, okay? So we distribute this. Negative 2 times negative 1/2 is that positive whole x, so just positive 1x or x. Negative 2 times y is negative 2y. And 1 times negative 2 is negative 2. That's our answer.
We have 1x.
You totally could. Yeah. 1x, x, both are acceptable answers, okay?
And it can be a plus negative, right?
Yep, and definitely that's a great question as well, okay? Can we have x plus a negative 2y? Is that okay? Yeah, that's 100% okay, okay? Good question, okay? Any other questions?